So then you can come back later and reread it again, right? And so let's not read that. This was a homework assignment, and I translated it into slides. So here's the answer. All right? So this is just to give you, right, we had the first example we did focused on how can I read something, remember it briefly in order to calculate, right, as I go along. And now we're going to focus on where do I put things and how do I move around to put things, remember things and move things, and how can I do more tape management. All right, so we're not going to do anything hard here. What we're going to do now is managing data on a tape. So, and the reason, let me tell you where this came up from. At some point, we might be able to prove that if a Turing machine with the 0-1 tape can do it, then then you can do it with the tape that has, the other way around. Suppose I know a Turing machine with an ASCII tape can do it. Now I want to prove that a Turing machine with a binary tape can do it, right? So here we're kind of converting from single-digit inputs to ASCII digits, kind of, right? So there the bit is 1. We convert it to a 1, but using more spaces, right? We're just spreading things out. So what's the problem is the input is a 0-1 string, and we're going to just we're going to insert 3 zeros before every character. Right? Everybody see that? The green over there is the exact same, and we inserted these zeros. So you see, we're not really doing any thinking. It's just moving stuff around. All right? Any questions about the problem? All right, so then what we need is what I always say in 30-101 is if you try to solve the entire problem all in one step, then you're going to panic and drown, right? So you want to do it one step at a time. And what tool do we do to do things one step at a time? What's Jeff religious about? Loop invariance. So we need a loop invariant. We need to jump into the middle of the computation and say what's going to be true in the middle, right? Some picture of what's true. And what's picture that's true at the beginning of the computation is going to look like the precondition. And at the end of the computation, it's going to look like the postcondition. And it's going to gracefully move between the two. All right? So we're going to jump into the middle of the computation and see what we want to be true. That's our loop invariant. A loop invariant is an assertion that says what must be true at the top of the loop. It's not an action, it's a picture. Right? We're going to describe what our Turing machine is going to look like in the middle of the computation. All right. So this is, I said already, right? All right. So here is the input, right? Here's the output. Now, one thing I didn't quite say is I didn't tell you where this output was going to occur. I just said we needed to produce it. And to make our life a little easier, if the input's here, let's produce the output there, right? If you really need it at the beginning, you could shift it back again. But now we're just doing that, right? And then you can see that makes our life a little easier, right? All right, so this is the input and the output. And now in that right there, you'll see I made 2 of the characters red, right? Why do you think I did that? We're in the middle of the computation. I want to say, where are we in the middle of the computation? How many iterations in do you think we're going to be? 2, right? Suppose I've iterated twice. What do I want things to look like when I've iterated twice? Right? I is some number of characters handled, and that's my loop invariant. My loop invariant is going to say there's some I between 0 and n. Here's a question. Does the Turing machine, does the finite state automata know the value of I? No, because it can't remember arbitrarily large numbers. So it doesn't know I. So somehow we have to store I on the tape, right? We could write I in binary. We could write I, right? But we're not going to do that. What are we going to say? Well, we're going to say 2 of the input characters have been blanked out, right? So the way we're going to remember that we've done that already, why do you need to know I? So that you know what you've done and what you haven't done. The way we're going to remember what we've done is we're going to blank out characters that we're done with. So 2 characters are blanked out. And when I say we're done with them, it's we've produced the output for them, right? Everybody see this is a really nice loop invariant. Everybody understand it? It tells you what I've done. In fact, the parts I've done, I've destroyed. The parts I haven't done are still ready for me to read. The parts the answer output I've done is there. Everybody got it? And where's my head? My head is right before the character that I need to read next, right? And I could have stated why did I put it there? I could have put it anywhere, right? I'm just telling you what my loop invariant is going to be. I decided to put it there, right? You could have your loop invariant be whatever you want it to be. This is my loop invariant. Everybody get it? All right. So then I think it's useful to say the hard part of the step. Well, there's 3 things with loop invariants. You have to say, how do I establish the loop invariant? How do I maintain the loop invariant? How do I get the postcondition? All right? But I usually do the middle one first because it's the harder one and it's the one that's really the bulk of the work. All right? So I'm going to assume that I'm flying from Mars and the loop invariant's true, right? So we have that I picture. And then I want to think, well, what do I want to be true after the iteration? Well, let's draw the loop invariant for the I plus 1 loop invariant. What's true then? Well, 3 characters are blanked out, and I've solved those 3 of them, right? That tells me what the data structure looks like at this point and what it looks like when I come around, right? So now what's my goal is, right, we're going to just take this example and we're going to write code that's going to turn the I example into the I plus 1 example, right? Does that make sense? Proof by example, we're going to just write the code to do that, and we're going to hope then that we can write the code in a way that it's generic enough that it will work no matter what I is or what the values are, right? Right? Everybody follow this? All right. That's our goal. All right. Oh, here we're going to do precondition to postcondition. I thought I was going to do it later, but we're going to do it now. All right? So here, what's the input? The input is that, right? How do you establish, or then I'm saying, well, what does the loop invariant look like when I've done 0 iterations, right? You want to say, how do I establish the loop invariant in the easiest, most possible way? Well, I like 0. 0 is a good number, right? So how many characters have I completed? 0 characters. If I've completed 0 characters, what does my loop invariant look like? Well, 0 characters have been blanked out. Where's the head? Just before the character that needs to be done first. What's after the input? Nothing, because I haven't done nothing yet. Right? Everybody got that? So that's the statement of the loop invariant. What work do I have to do to establish the loop invariant? What work do I have to do to go from the precondition to the loop invariant? Nothing. absolutely nothing. Right? Absolutely nothing. But what she said is go to the next line. So you could say my start state is I'm in line 0, and the top of the loop is line 1. So I'll go from line 0 to line 1. Right? I could do that. And I don't think anybody would regard you too much for doing that. Right? But another option is what? How do I do nothing? I'm going to have my start state be just that I'm at the top of the loop and I'm ready to go. Right? The start state will say I'm in line 1. What does the loop invariant remember? Does it say anything that I'm remembering anything? But in my mind, in my blackboard, am I remembering anything? No. So what should the start state be? Line 1. Start state's line 1. And I'm ready to go. Right? Everybody buy that? So nothing happens. Do I talk about the start state? All right. How do I get the post condition? All right. So I want to think, well, what's my exit condition? I exit when I'm done them all. So what does the loop invariant look like when I'm done them all? Well, it's going to look like something like this. And how do I know I'm exiting? Well, somehow the next character is a blank, right? And what do I do then? Yeah, we just exit, right? We just exit. All right, everybody buy that? All right, so now we're going to do this loop invariant thing. All right, handle one character. All right, so we draw a picture of what's true right now, right? And we try to take one step to there. And we write machine code that's going to do it. And what are we allowed to do? What is a Turing machine allowed to do? It's allowed to move a character at the head. It's allowed to move the head. It's allowed to write something on the head. It's allowed to remember some finite amount of stuff. Right? So, let's do it. Oh, here's our code. All right, can people read that? Is it too small? I was worried it was too small. As we code through here, we move the head. But if it's too small, then I will. Why isn't it letting me? Oh, we have to enable in editing. All right, is that better? Can you read that? All right. All right, everybody see where we are? All right, this was a 1, and this was a 0. Everybody got our thing? Because we're not going to be able to flip through them if we're looking at this big screen. All right, so we have the loop invariant is true, right? So you're at the top of the loop. You believe the loop invariant is true. So draw a picture, right? If you're trying to figure out what's going on, draw a picture of what's true. Everybody got the picture? Right. And then, oh, where's the head? Right? The head is here. Everybody good? So what do we have to do first? We have to move the head. Move the head one right. What do we do now? Oh, now the head's here. And now what do we do? Well, in our blackboard, we take the value 1 and we store it in a variable called a. Right? A is the bit at the head. Right? And we write a blank there. We might as well blank it out. Right? So I'm remembering this, and I blank it out. Right? And it used to be a 1. Right? And then what do? We move the head right until it reaches a blank. Right? So we're going to go, head is going to go right. Oh, till we get a blank. Right? And then we move the head right one more, which moves it into the output. Right? Ooh. So now the head's here. Everybody good? Then we move the head right until we're on a blank. So we go right until the head is here. Right? And then we right at 0, go right. Right is 0, go right. Right is 0, go right, and write A. Right? So we write 0, 0, 0, 1. That's what we did. Right? What do we do with the head? Well, I could have, every step you should do something with the head. But here I'm saying, let's just leave the head where it is. All right? So, right, just leave the head where it is. All right, now move the head left until it's a blank. Right? Luckily, I'm not looking at a blank. Right? Because if I was looking at a blank, I would stop right now. But I move right until I get to a blank. And then what do? I go one step over. And then I move right until I get to a blank, which puts me here. And then what's happened? I'm happy. Right? Everybody see that? That was my loop. Wasn't that good? Yep. You mean the B after? Oh, the input starts with an infinite number of blanks. Any other questions about it? All right, so when I first gave this to you, it was an assignment in which you had a week or two to do it, and you had to come up with this code yourself. All right? But given that you only have an hour and a half divided by 2 to do this question, right, I give you the code. And the truth is this code is longer than you'll have time for on the test. Right? So the code won't be this long. But it will be, this is the level of difficulty. Right? So now let's take this code, right, and convert it into a Turing machine. All right? So I think you can see the code on the bottom. All right? You can half see this, but we'll tell you, we'll follow through and do it again. All right? Let's wind our in fact, we don't need to do it again. We'll just go from here down to here, and we can take a next step. All right? Everybody ready? We're going to do it again? All right. So what you first need to say is, if the loop invariant's true, I'm at the top of the loop. All I know is the loop invariant's true. What state am I in? Right? That's the first thing you need to do. You read my loop invariant to know what state you're going to be in. Right? One of the questions is I separated them to make it easier for you. I separated it into 3 questions. Right? The one question is, give me the meta Turing machine code to maintain the loop invariant, right? A different question is establishing the loop invariant and getting the postcondition, right? But this question, so how do you start? You assume the loop invariant's true, right? So you read the loop invariant and you say what state I'm in. I know I'm in line 1, but I'm not remembering anything, right? All this stuff is true about the tape, but I don't know that, right? I can't see it. It's not in my own brain. I'm just trusting it, right? Right? You could say I know it because I'm in line 1. Line 1 means if everything is going right, the loop invariant's true, and the loop invariant, it should look like that. But I'm going on trust, right? So everybody buy that? And what am I assuming I'm looking at? Well, in this example, I'm looking at a blank, and if I'm not looking at a blank, then what? I panic, right? So we could fill in the table. If I'm looking at a 5, panic, right? But for your quick test, you don't have to do error correcting. So you can just skip it, right? In general, when you're writing a Turing machine, you have to say, if I'm in this state and I get this character, what do I do? If I get this character, what do I do? If I get a blank, what do I do? You have to specify the whole thing, right? But here, I'm not making you specify the whole thing, all right? All right, so what state do I go in next? Well, the action is I move my head right, right? So what state should I go into? Line 2, exactly. Do I know anything new? No, I don't know anything new. I'm in line 2, right? What am I looking at? Oh, what do I write? Right? I write a blank because I'm not messing up that blank, right? Everybody see I was looking at a blank, I wrote the blank, I moved right. Right? Everybody good? So now, what state I'm in? Oh, here this is just saying the panic, right? If you want to fill it in, what do? I panic. Right? Everybody make sense? And you can write that if you want to, but you don't need to. Yeah? So is this the meta? Yes. Yeah, we don't have any for alls yet because I don't know anything, right? In fact, if you're going to count how many states are there, how many states are there with line 1? 1, right? There's 1 because I'm not remembering anything, right? And you can kind of, how many binary bits am I remembering? Suppose that I'm remembering in binary bits. That's how many states there are, right? Well, I'm remembering 0 binary bits. So how many states are there? 1. Right? Everybody got that? All right, so what do I do next? All right, so now, what state am I next? And you can just, it makes it really easy on the test. You just copy that down, right? You just copy it. I'm now in state line 2. And what am I reading? Hopefully I'm reading a character. Now we're doing the meta stuff. What's my characters? 0, 1, because I'm filling in the table, right? If it's filling in the table this way, right? Here we have table. We're looking at line, the state Q, line 2, and there's 2 entries, 0 and 1. We're filling this and we're filling this in, right? So what state do I go? What are my actions? The bit, I read it in and I store it in a variable called A. I write a blank and I move the head right. Right? So how do we do that? Right? What state I'm in? I'm now line 3. I'm remembering that A has the value that I read in. And I wrote a blank on top of the C. It was a C, 0, 1, but I zeroed it out because I'm done with it. And I moved the head right. Yeah? I often, that's a good question. If I were to go through and make all the slides again, maybe I would use C primes everywhere, just so that primes are values. But I didn't do that the first time, right? what did I do? When there's a variable x, then the value has to be x prime. But I don't have a variable c. So I'm just using c as c. C is a value, right? You need to distinguish between variables and values, and here I don't have a variable, so I made the value c. Sorry, it's a little confusing, but it's there. All right, everybody got this? In fact, it might not be so bad. I might be able to do a global change of all c's in the slide to c prime, and sometimes it would go off the edge of the screen and things wouldn't line up, but it wouldn't be too bad. All right, so everybody get this? Right? This is what you're going to have to do in the test, right? All right, so now, there up in the blackboard, I wrote the value a equals 0, right? And I blanked it out. Watch it. I blanked it out and I moved my head over. Right? Everybody follow? Right? So now what state I'm in? I'm now in state. Oh, here you're going to have a C prime. Right? Why do I have a C prime? Because I have two different C's. Right? So I'm in the state where I'm remembering that A is C, and I'm in line 3, and I'm looking at some character, right? Which is a different character than this. Everybody see if you made this the same, I would think that's not good, right? I'm remembering one value. This is a value I'm remembering. This is a different value that I'm looking on the tape. Yeah? Yeah. Yeah, you can do different things. Yeah. It's a local variable that our compiler is going to deal with. Right? Everybody good with this? I guess I was using C's because I'm saying, hey, C's are the things I'm reading off the tape. All right, so what's our action? Go line 4. Line 3 says, move right until it's a blank. All right, so if it's not a blank, what do I do? I move right. Right? This is a loop, right? That little state, that line 3 is a little self loop, right? So it's implied that I stay in line 3 until, right? It's kind of a for all loop. So I stay in the same state, and I don't want to destroy the character, so here it's the same C prime. I'm reading a C prime, and I'm writing a C prime, and I'm moving right. Right? Does that make sense? Right? And what is this going to do? It's going to keep doing it until it gets a blank. Right? So watch our little man up there, right? It wasn't a very long word, but he goes there and then he goes there. Right? And then it's a blank. Yeah? These? Yeah, because I'm assuming my tape alphabet 0, 1. Yes. Yeah, but so I'm saying if C prime, what I'm saying here is if I'm in this state and I read something that's not a blank, go right. Now I'm saying if I'm in this state and I read a blank, right? So let me give you a little tip. Suppose I'm in this state, and when I read 0 through 8, I need to do something. But if I'm in this state and I read a 9, then I have to do something special. Right? Then what do I say? I say for all C prime in 0 to 8, when I'm reading a C prime, do this. And then I say, well, when I'm reading a 9, do that. Right? Does that make sense? You have to fill in the entire table, but you can do it in blocks that make life easy for you. Right? I'm doing all of these in one block because for all of those I do the same pattern. Right? But maybe 9 has a particular meaning, and so I do something different. Right? Does that make sense? All right. So what do I do if it's a blank? Right? Right? What do? I move right to it's a blank, and then I just go to the next line, right? And, I didn't quite say, do I go right again? But I did, right? So here I went until I got a blank, and then I'm going to go right, and that puts me here. Yeah? Here? Oh, yeah. So what I recommend doing, because I'm lazy and I only have so much paper, I recommend having a set of variables that you'll use for the entire test, and you write them at the top of the screen, at the top of the page, right? And so what I could write, well, for all C and C prime in 0 through 9, and for all C double prime in 0 through 8, right? I write that at the beginning of my at the top of my page, and then when I want it to be limited to the smaller range, I do that, right? Later down in the thing. Does that make sense? That's the way I would do it, but you could write it separately for each line as well. Whatever works for you. That is every way that works for you that's right and understandable. Yes? Oh, good question. Good question. Anybody know why I jump to line 5? Line 4 is moved to the right. Remember I just said, oops, my code doesn't tell you what you do when you get to line 4, when you get to a blank. Right? Line 3 says, go until you get to a blank. It doesn't say what to do. And then I said, oh dear, what do? I don't know what to do when I get to a blank. And then what I do is I should go to line 4. In fact, I think, let's see. Do I say anything here? No, maybe I didn't. Right, so what you could say is what I should do is go to line 4 and not move the head. Right? And then at line 4, what do I do? Well, at line 4, I move the head and go into line 5. Right? So I just did it in one step. Right? Every step, you should move the head once. Right? So that's what I did. Yeah? Here? Well, these are two cases. Case 1 says, if I'm in this state and I read a C prime, move your head, write the C prime, write the same character there. Right? So I'm flipping through here. I'm reading a 0, I write a 0. I'm reading a 0. I'm reading a 1. I write a 1. I read a 0. I write a 0. I read a 1. I write a 1. I read a 0. I write a 0. These are all my C primes. Then I get to a blank. Where's my blank? Then I get to a blank. I move right. Right? And now I'm going to do it again. Right? So now we're in line 5. And what do I do in line 5? We do it again, right? Again, we move right, as long as we get a blank, right? Right? Move wrong as long as it's a blank. And then again, it doesn't say what to do when you hit a blank, right? So if you hit a blank, right? So what are we going to do when we hit a blank? We got this. Right? I don't know what to do. So what we'll do is we'll go to line 6. Right? And so let's see what we got here. in line 6, I'm going to write the blank and keep my head stationary. I don't know why. Maybe we're trying the other thing. So here what we are. Let's. I guess it's at the top here anyway, right? So let's go. Right there I am, right? I moved right until it was a blank, and this time I decided, right? You could do different things, and this time I decided to keep the blank there and go into line 6. All right? Now I'm in line 6. What do I do? All right? I write a 0, move right, write a 0, move right, write a 0, move right, write A. All right? How do I keep track of how many zeros I've done? It's the different line numbers, right? So in line 6, where's my line 6? Come on. Good morning. Oh, I right-clicked it. All right. Good morning. Okay, here we are, right? If I'm on line 6 and I'm reading a blank, then I go to line 7 and write a 0. In 7, I write a 0 and go to 8. In 8, I write a 0 and go to 9, right? Moving the head right. Right? Does that make sense? I'm counting my blackboard up there is counting lines, so it's counting how many zeros I've written. Right? Then, now I'm in line 9. What do I do? I'm looking at a blank. I write A. Right? So here, A, I'm in the state where A has the value C, and C is one of these. Right? So what do I write? I write the value C. Right? Yeah?
Why is from 6 to 9 is looking for the brand?
Looking for what?
A brand.
Because we got to the end where there's a blank, and now we have to write 00A. Right? See, that's where this is we moved right until we got a blank. And now what are we doing? Now we're putting in the, right, we got, what we did is we read the C from the left. And we remembered the C as we came along. And now on those next blanks, we're extending the output. It's always going to be blanks, because there's an infinite number of blanks. All right, and on those blanks, we write 001. Right? Does that, everybody follow that? Yeah? Oh, if you're in line 4, I wouldn't even have a state called line 4. Right? There's just, that state doesn't exist. Right? So if I was counting the number of lines, I would just say line 4 didn't exist. All right, because then, all right, so now I wrote 00 character, right? So now I'm looking at the character. What do I want to do? I don't need to move right, right? I could start moving left, right? But I'm a little nervous about writing separate code for, So I'm going to leave the moving left to the next line, right? And I know the next line says, keep moving left until there's a blank, right? So if I was on a left, then I might want to do that first left. But I'm not on a left, so I'm going to leave my left going to my next line of code, right? And that's why I just said, write the character, stay there, go over to line 10, and line 10 will move us left, right? Does that make sense? All right. Now, what I didn't say, you can forget the A if you want, right? In fact, right, so here, Here I'm saying I wrote the character, and then I forgot. I don't need to know anymore. Right? Everybody see that? Decreases the number of states. Yeah? All right, now what do? I'm now in line 10, and I'm reading a character. What do? I go left. Right? And I keep staying in line 10, stay in line 10 until I get a blank. When I get a blank, what do? I write the blank, and I go further left. Right? So that read me past the output. Then I'm in line 12. What happened here? I was in line 10. What happened in line 11? 12. Here's an exit condition. All right? So we move left, and if there's a blank, what are we expecting there to be? To be more input. Right? It's supposed to be more input. And if there's no input, here we're saying if the head is on a blank, then exit, because there's no more input. Right? So if we're on a blank, then I move to line 15. All right? Why did I move to line 15 and not exit? Or this is a subroutine, and I got more to do. Right? I haven't really quite told you what this whole program is. If we're now done, we could exit. But maybe there's more code after this. Right? Now, if I read a character, then right, we don't have to go fast, right? We came and got a character, right? Right? Move the head left until it's a blank. Well, I don't know. I'm losing track a little bit here. But here we came. Here's our input, right? So we came until we got to this blank, and then we moved left, right? And if it was a blank, we got, all right, we got to go back to get this guy, right? So we keep going left until we get to a blank, right? So that's what we're doing is line 13, we move right, left until we get to a blank, right? And then we move left, and now we're at this blank. And what line do we want to be on now? Right? We go back up to line 1. Does that make sense? Do you have a question?
If you're line 12, previous slide, and at the second bottom line, you're saying at line 12, if we read C prime, which is either 0 or 1, shouldn't we be panicking and not?
No, because we were here, and we moved here in line, we moved left until we got to a blank, and then we moved left one more. So we went through here till we got to the blank, and then I moved one more, put me here. Right? Now I'm here. If this is a blank, then I have no more characters to read. Right? Otherwise, I mean left to a blank, and then I'm established my loop invariance true again. Right? Because I'm 1 before the first character, and I'm ready to go. Yeah?
Why is it line 15, not line 14? Because there's no 14 on the...
I don't know. Maybe it's line 1,000,000 because you've got to jump out of the subroutine. I don't know. Maybe I was counting in loop and in algorithm. I don't know. Yeah?
So after line 13, you move head to the left until it's at a blank.
Yeah.
Do we just end the loop?
Yeah, so then let's see what we do then, right? Let's go over to line 13, right? You move left until you get a blank. And when you get a blank, what line do you go into? You go into line 1, right? That brings you here. The guy's on this first blank, and we're back at line 1, and the loop invariant's true, right? We went from here to here. We're happy, right? We went from the loop invariant being true to making progress and making the loop invariant true. You have to connect up the pieces, right? So when I say you don't worry about the whole computation, you worry about one step, but you got to make sure that the steps line up, right? The end of this step lines up with the beginning of the next step. That's what you need the loop invariant for, is to get your steps to line up. Right? Everybody buy that? How do you feel about it? Can you do this sort of thing? Right? And there's little nuances, little nuances. Oh, why did I do this? Did a little do this? Unless everybody's getting perfect, we're not going to care about those nuances, right? But maybe, since, if this exam is so easy, then everybody will get perfect, and then we'll mark you on those nuances, right? So work on all your nuances, but if you get it, don't panic if you're getting some of them wrong, right? Yeah?
Would you be able to just explain the loop invariant picture for this again? Like what we're looking for?
Yeah, suppose so. What's our loop invariant? Is we've done some of the input, right? And how did we remember that? We can't remember I, right? If we were doing Java code, we would have a loop over I, and we would access the I input, right? But we can't remember I. So the way we're going to remember it is we're going to blank out the things we've done already, right? So here the loop invariant I, if I is 2, we've blanked out the first 2 inputs. They're red. Those 2 red B's are things that have been blanked out, right? And where's our head? Well, we decided to put the head at the last B's, just before the first character, the B before the character we want to read, right? That's where we decided to put it. And then what did we also remember? Remember, it's that the remaining inputs there in green unto a B, and then we have the output, right? That's the loop invariant, right? And how do you get the loop invariant? You kind of, why do I want to be in the middle of the computation? I write it down in English. I write it down in pictures. We explain it over and over. Hopefully everybody understands what it is. All right, everybody getting this? Right? And that's the entire algorithm. Any questions?